Hello mathematicians and welcome to day one of triangles. Today we're going to be going over some review. So hopefully back in elementary school you learned that there was different types of triangles. Spoiler, there's 3 different types of triangles. But today we're going to be focusing on just 2. And the first one is isosceles triangles and the second one is equilateral triangles. So over here on this corner, you see that I made a cute little notes section for you. Hopefully you have this worksheet in front of you and you're following along taking notes. So the first triangle we're going to be talking about is the equilateral triangle. Equilateral. So hopefully the prefix equal gives you a hint as to what this triangle means, because equal sounds a lot like equal, which is basically our definition, which is that all sides of the triangle are equal. So all sides are equal. And usually the way that we denote this on paper are these red lines right here. So if you see 3 red lines on each side of the triangle, that means that they are all equal sides. And it also follows that our angles are the same. So let's add that in. All angles are equal. Now these come in pairs. So if all sides are equal, then it follows that all angles are equal. It's not like an or kind of thing. It's an and kind of thing. The next type of triangle we have, let me fix this thickness real quick, is an isosceles triangle. I'm pretty sure how that's spelled. Now let's talk about the breakdown of the word. Iso means 2. Hopefully you've heard it in science with words like isomorphic, which means 2. And les means legs. So just like the last triangle, this gives us a very direct hint at our definition, which is that an isosceles triangle is a triangle that has 2 sides that are the same. So 2 sides are equal. And likewise, if we have 2 sides that are equal, then it follows that 2 angles are equal. Now, the only thing about this is that we have to be careful about which angles are equal or which sides are equal if we're given one or the other. So let's go ahead and jump to question 1. Find the value of x. So right here, I see that I have 2 colored in angles. So that tells me that this is an isosceles triangle because I have 2. So you might be tempted to say, oh, well, it has to be x equals 7 because 2 sides are equal. But let's back up, because how do we know for sure that those 2 are equal? What if these 2 sides are equal, or these 2 sides are equal? We could also have these 2 sides are equal. What we have to do is that we have to double check that they are equal. You might be saying, well, how do we know which ones are equal? Well, the way we do it is that we look at the sides that are equal. So I see that this side is equal to that side. And we're going to look at the sides that are directly across from these angles. So the one directly across from this angle is right here. So that means that this side is congruent to the corresponding side of this angle. So again, we're going to go across and it's this one right here. So yes, we got lucky this time. The 2 sides are equal, or the sides that were given. So it then follows that x has to equal 7 because it's an isosceles triangle. All right, let's do question 2. So again, we have an isosceles triangle because I have 2 angles that are equal, isosceles. And we're going to look at their corresponding sides. So the one that's across from this angle is right here. And the one across from this angle is right over here. So we got lucky again. X and 6 are the sides that are meant to be equal. So x should be equal to 6. Pretty easy, right? I'm going to go ahead and jump onto problem 10, which is a little bit more difficult. So here we have two triangles, right? We have this one right here, and then we have this one right here. Both of these triangles are isosceles, right? Because if we focus just on this triangle, I have these two markings right here. And then on this side, I have this marking and this marking. I'm going to do that just to let us know which are equal. So we're trying to figure out what x is. So I'm going to focus in on this triangle right here, okay? So what I'm going to do is I'm actually going to block out this one just so that we don't focus on it for now, okay? Let's pretend we have just this triangle. So in this case, we're given that two sides are equal. On problem 1 and 2, we were working with the angles, remember? So this time we have to find which are the corresponding sides. And it's the same thing. The corresponding angles. We just go across. So if this side is one of the congruent sides, then all we have to do is we have to follow it along to find the opposite angle. And it's going to be this one right here. So let me go ahead and erase this. So that's one side. That's one angle. We still need to find the second angle that is congruent. So I'm going to go with this side right here, and I'm going to find the angle that is right across from it. And it is this one right here. I'm actually not going to color it in because we're going to need it in a bit. Now the problem is oh shoot, we're not given any of those angles. But let's think real quick. So if I focus in on this section right here, I see that we have a little square. Now, if we remember, we have a little square like this. That means that this is equal to 90 degrees. So our whole square is equal to 90 degrees. Our whole angle, I'm sorry. But our whole angle has this extra triangle that we really don't want to pay attention. But hold up, we're given that this little smidge right here is equal to 28 degrees. So that means that this little red smidge plus the little blue smidge angle should equal to 90 degrees. So what I can do is actually 90 degrees, and if I subtract 28 from it, I should get my blue angle. So if I pop that into my calculator real quick, that is 62 degrees. So that means that this is 62 degrees right here. 62 plus 28 does in fact give me 90. So this is 62 degrees right here. Well, hold up. We just found out that two of these are congruent to each other. So that means that this is also 62 degrees because it's an isosceles triangle. So now let's just use the fact that we know that a triangle is equal to 180 degrees. So that means 62 degrees plus 62 degrees plus my missing one should equal 180. If we combine like terms, this is 124 plus x equals 180. If I subtract on both sides, so let me show you guys, minus 124 minus 124, this crosses out. I get x is equal to 56. By the way, I'm doing this in my head, so if my calculations are wrong, I'm sorry, I don't have a calculator on me. So I get that x is equal to 56. And that is how we can use triangles, isosceles and equilateral, to figure out missing angles and sides. So go ahead and give some of these a try. Once you feel like you have a good idea on this, jump onto Delta Math or the next video. I'll see you.